Session, we will be tackling regular expressions for regex in Python. So the first thing that you have to do is to import that's regex library. So what is regex? Regex is a sequence of symbols and characters expressing a string or pattern to be searched for within a longer piece of text. In the context of text processing, we use this to extract the parts that we need from a text data. And here's your cheat sheet for the regex syntax. It is quite daunting for starters, but that's okay. The good thing is we have a website that we can use for testing purposes. We use that to ensure that our regex syntax works before running our Python code. So it's this website here. If I click that, it will open this one, the regex 101 website. And you could just put your regex here and your test string. So let's make some examples later. Basic regex. There's red.match, so it checks if the pattern matches the string. The pattern must occur at the start of the string, else it will return nothing. If the regex has a capturing group denoted by parentheses, then red.match will return the substrings that match the pattern inside the parentheses. So for example, if we have the I am Jude, Jude, la, la, and then you're looking for Jude, then you will see no match. Why is that? Let's check. But if you use this one, I am there will be matched. So why is that the case? Because the pattern must occur at the start of the string. Jude is not at the start of the string. That's why it says no match. That's what red.match does. You can type it here. This is our test string, and we type Jude. We should use Python, by the way. So basically is showing you all the instances of Jude, but because we're using red.match, it has to be at the start. Okay. We could make use of the dot and then star. So dot captures everything, and star or asterisk means 0 to many. So what does it do? We can show it here in our tester website. So again, dot matches everything. You could look at this one, so you're guided. On the right side, you will see that dot matches any character except for line terminators. And then the asterisk matches the previous token between 0 . Sorry, I had to drink. So the asterisk matches the previous token between 0 and unlimited time. So that means any character and then unlimited times until it sees an am token. And then the same goes for this one. So all the characters after am, that's what's happening. So take note that there is a space here. So it captured am, and then this capturing group captured everything before am, and then the right capture group captured everything after am. That's red.match. So it matched. And then it also shows you the location of that match. Because we're using the dot asterisk, it captured all characters. There's also red.search. It returns the first instance of the substring matching the pattern. Unlike match, wherein it has to occur at the start of the string. So if you run this, basically, it will return something if it exists there in the string, if that token or substring exists here. That's what it does. So as you can see here, I am looking for Jude in the original string. There is a match. It returns Jude. Yes, there is. For I am, same goes. If we use the capturing group again, of course, it will return that. It also return the capture groups by using dot groups parentheses. So it will return those tokens or substrings inside the parentheses. In this case, it returned I and Juju, Lala. Because the first capturing group captured this one, which is just I. If you go back here, it's I, that's the first capture group here. And then the second capture group is this. Okay. And then if we use Jude instead, inside the capture group, then it should return Jude and then ignore everything else. So if you copy this one and put it in here, now it is Jude that is inside the capture group. There's also red dot find all. It returns all substrings matching the pattern. It's a list. There are 3 Judes here, so it returned 3. For am, it's just 1, so 1. Hello does not exist, so nothing. There's non-greedy and greedy searching in regex. By default, plus and asterisk are greedy when it comes to searching. This means that it will try to capture everything until the last occurrence of the pattern on the right. Here is an example. So similar to this, the one earlier, as you can see, it is greedy in the sense that it did not stop here. There are lots of Judes, but it captured everything up until the last occurrence of Jude. That's greedy searching. That's what happens when you use asterisk. Going back. Okay. So if you look at the groups, the first group is this one. I am Juju, Lala. Second index contains the first capture group. I am Juju, and then this one is the second capture group, Lala. So how do we prevent greedy searching? We add question mark after the asterisk or plus. Plus is 1 to many. Asterisk is 0 to many. So that means the token has to be there at least once. There has to be at least one occurrence if you use plus. But for asterisk, it doesn't matter. If it doesn't exist, that's okay. So as you can see, we have added a question mark here. That's the only modification that we will be doing. So the original regex, and we add this one. And you can see it shifted here. So it's now non-greedy. There's also look ahead and look behind. So regex look ahead is used to get words before a certain pattern. Here's the string. We copy it here. And then we use this one I've created back then. This is our regex. Okay, so what do we have to do? We demonstrate how regex look ahead is being used. So let's break it down. Again, the dot refers to all characters, and then plus, that means it has to exist at least once, and then until the end, because this is greedy. Again, it's greedy. So it will stop up until hello. Positive hello. So it will stop here, right? Okay. How can we prevent greedy searching? We add the question mark. Because you have many instances of hello. We want to capture all of the hellos. Earlier, we only captured the last one. So how do we do that? We add this one, so it becomes non-greedy. If it encountered hello, then that's another capture group. Then for the next hello, that's another capture group. Same goes for the others. So you have many capture groups here. This is what you end up with. They're all separate items. Regex look behind is the opposite of look ahead. It is used to get words after a certain pattern. So same string, but we use this. So again, look behind. Look behind. So hello, and then after that, all the other characters. It looks behind. So we want to capture this. But hello has to be seen first. And when you do that, you end up with this. This is what you captured. Find all. You do not include the hello. You're only looking at the substring after that. Because you're looking behind. Combining look ahead and look behind. So this is an example, getting words in between two patterns. What if we do this? So basically, all the tokens between hellos. So there's look ahead and look behind. So this is the look behind, and then this is the look ahead. So everything that's in between them. So in this case, data is between two hellos, so we capture that. Mine is between two hellos, we capture that, and same goes for the others. So we get them. And that's what we get here. So that's the usage of look aheads and look behinds. There's also name capture group. We just add this syntax here. So question mark P, and then the name of the group, and then your typical regex. What is it used for? So that you have names for the different substrings that you extract. For example, we copy this one. Yeah, this is our string. We want to extract the letters and the numbers. So we name them. Letters, that's the name of that capture group. And then the pattern is \D. And then there should be 3. So a 3-digit token basically for letters. Non-digit, sorry. So matches any character that's not a digit if it is capital D. And then the length should be 3. For the numbers, it's small d. So it should be 3 characters. You capture this one, numbers. So if you look here, look at the group names. I did not run. Letters A, B, C, numbers 1, 2, 3. Because we use Reddit search, not find all. But what if we want to get everything, all the occurrences? We use this find iter. With that, you will get multiple dictionaries, and you'll have to loop. So just the same regex, but you use red.find iter, and it has to be in a loop, and you get everything. So another example would be this one. And then we use this pattern. So we're extracting the title, name, year, month, day. So for the title, it should be ending with a dot. So you have to have this escape character here, \. So it captures a dot, because by default, dot is for all characters, right? And then what's after that? Name. So name has to be alphanumeric. That's a -Z, and then the capital version of that, the uppercase version of that. What else? The year should be 4. digits. So small d, then 4. Then month, small d, 2. Day, small d, 2. So you capture those. And as you can see here, I have extracted all of them. That's regex.